Pre-calculus. This is Unit 10, conic sections. Everybody loves them. All right, so as you can see here in the picture, I have several pictures of a double napped cone. That just means you have cones that share a vertex right here, and of course these are called the bases right here. And conic sections are basically the shapes or images or figures that are formed when a plane intersects this double napped cone. So here's the deal. If it bisects it at an angle like this, you end up getting a parabola. If it's perpendicular to this axis right here, you get a circle. If it's tilted, you get an ellipse right here. And if the plane cuts both of the cones, you get a hyperbola, which is essentially, it just looks like two parabolas that are facing out from each other. Okay, so we're going to define a few things, and then we're going to talk more specifically about a parabola. So the first thing we want to talk about is the definition of locus. Locus is a set of all the points that fulfill a geometric property in case it comes up. I don't think you'll ever be asked that. The definition of a parabola represents the locus of points in a plane that are equidistant from a fixed point called the focus. Okay, we are going to talk about that. And a specific line called the directrix. So let's see what a picture of all of this would look like. Okay, so I'm going to start with the basic form of a parabola. So if I'm looking at this right here, y is equal to a times x minus h squared plus k. Okay, so there are some important things you need to recognize here. The first thing you need to recognize is that a, h, and k will always be replaced by actual values. The x and the y will remain x and y. So what does this tell me about my parabola? Well, if I have a parabola, okay, and this parabola is actually illustrated by this equation because it's y equals. This a right here is positive because there's no sign written there. So that means that our parabola opens up. There are several pieces we need to know here. Okay, this is called the axis of symmetry. I am just going to use an abbreviation, axis of symmetry. It is always a line. It always goes through the vertex. This vertex is HK, and you guessed it, that H and that K. Okay, now, other things that we need to know. There is a value we have to calculate for a parabola, and it is called P, and it is found by taking 1 over 4a. So whatever a is, that's the a I'm talking about right there, okay? Now, when we find P, here's what it's good for. It tells me that it is equidistant from the vertex to two different places along the axis of symmetry. So that leads us to talking about these little guys right here, focus and directrix. The focus is always on the axis of symmetry, and it's always an ordered pair, and it is always inside the curve of the parabola. So this right here represents the focus. All right? Okay, there is a chord that goes through the focus. That is called the focal chord. The focal chord is actually found by the absolute value of 1 over a. And yes, it's the same a as up here. And that just tells me how wide to make my parabola. It's just a guide, and it always goes through the focus. That's why it's called the focal chord. Now, the distance from the focus to the vertex, that is P, this value right here, okay? Now, the other value, the directrix here, this line, this is also going to be part of our graph, and guess how far below the vertex this will be? It is going to be P as well. Okay, so our directrix will look something like this. Okay, so there's our directrix. Okay, so that's pretty much the long and short of a parabola. That's all of the information we need. Now, things will change according to how the equation is written. Something else I want to point out, the directrix and the axis of symmetry are perpendicular to one another. All right, so this is what your parabola will look like when you have y equals positive a times x minus h squared plus k. All right, so now let's talk about what it will look like when y equals negative a times x minus h squared plus k. That means that you're going to have a parabola that opens down. So here's my axis of symmetry. Here's my vertex. My focus now will be in here. My directrix will be here. That's how that works. And of course, the focal chord will be right through there. All right, what about when my parabola can open up right or left? Okay, this is where things get fun. If you have a parabola equation that looks like this, there you go. A is positive, that means it's going to open to the right. So now your axis of symmetry is this way. Your directrix is here. Your vertex is still HK, even though the values have switched location. And your focus is right here, focal chord right here. All right, so what if x equals negative a times y minus k squared plus h? That opens to the left, just like that. Axis of symmetry, directrix, focus, vertex, focal chord. Just like that. That is just the general information about a parabola. In other videos, we will do specific examples.